This is the first chapter, Chemical Reactions and Equations. In this part, we are going to study the topics related to chemical reactions, chemical equations, and their balancing. So, first of all, how we can determine visually that chemical reactions took place? It's by four effective ways. That is, change in state, change in color, evolution of gas, change in temperature. So coming on the first topic, that is chemical equation. Here, chemical equations are written in two ways, that is word equation and a symbolic representation of chemical reaction. So first of all, I'm going to give a small example for word equation. When we say a magnesium ribbon is burned in oxygen, it gets converted to magnesium oxide. Thus, it can be written as, in word equation, magnesium plus oxygen gives magnesium oxide. Do you know why we write magnesium plus oxygen on the left hand side and why magnesium oxide on the right hand side? To understand this phenomena, we have to understand few basic rules of chemical equation. In a reaction, we can see three things: reactant, product, and an arrow. Coming on reactant, the definition is the substance that undergo chemical changes in the reaction are known as reactant. For example, from the previous equation, magnesium and oxygen. Reactants are always written on left hand side with a plus sign in between them. Moving on to products, it is said to be a substance which is formed during the reaction. It is called as product. And for example, we take a magnesium oxide. Products are always written on the right hand side and they too are separated with a plus sign. Talking about an arrow, it's placed between reactant and product. Second point, used to separate reactant and product. Third point, it always points towards the product to show the direction of the reaction. So moving on to symbolic representation, we will learn how to write a word equation in a symbolic representation. So we are taking that previous example of magnesium plus oxygen giving magnesium oxide. So to write the word equation in symbolic representation, we should know the formula or symbols of those elements. So magnesium is written as Mg, oxygen is written as O2, and magnesium oxide is written as MgO. After substitution all the elements on the place of words, we get this equation as result. Have you noticed that here on the left hand side there is 2 oxygen atom and on the right hand side there is 1 oxygen atom? Why it is like that? So from this question, let's move on to the next topic, that is balancing chemical equations. So from this equation, we can say there is a difference in number of oxygen atom in the equation. So the mass is not the same on both the sides of the equation. Thus, it is considered as unbalanced. So such chemical equations are called as skeletal chemical equations for the burning of magnesium in air. So let's learn how to balance an equation. Here we are taking example for ferrous, like example equation is Fe plus H2O gives Fe3O4 plus H2. So step 1 is we have to draw boxes around each formula. Formula are Fe, H2O, Fe3O4 and H2. Now list down the number of atoms of different element. Elements are F, H, O. F is ferrous, H hydrogen, O oxygen. Now we will make 3 columns. One for element, another for number of atom in the reactant, that is LHS, and another for number of atoms in the product, that is right hand side RHS. So now let's count the atom of the elements on both the sides. On left hand side there is 1 ferrous and on right hand side there are 3 ferrous. Then on both the sides there are only 2 hydrogens. Then on left hand side there is only 1 oxygen, but on the right hand side there are 4 oxygen atoms. So now it's clear that on right hand side ferrous and oxygen has more number of atoms, and there is a law of conservation of mass, that is the total mass of the element present in the product of a chemical reaction has to be equal to the total mass of the element present in the reactant. In short, it states that the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance the skeletal equation of ferrous. Step 3. We have to start balancing and we have to see the compound that contain the maximum number of atoms. Here in Fe3O4, the oxygen has more number of atom. That is, it has 4 oxygen atom on right hand side and only 1 oxygen atom on left hand side. So to start balancing oxygen atom, we have to create 3 columns again, one with atom of oxygen in reactant and another one is in product. And initially in reactants, 1 atom of oxygen is present in H2O, and in product 4 oxygen atoms are present in Fe3O4. As we see, there are 4 oxygen atoms in the product and only 1 in the reactant. So in order to balance, we have to multiply 4 with the 1 oxygen atom in the reactant. So to balance oxygen, we have to put coefficient 4 as 4 H2O. We have to put 4 in front of H2O. Still, this equation is partially balanced, not completely balanced. Still, Fe is remaining, still hydrogens are remaining yet to be balanced. They are going to get balanced in the next